Hello dear learners, this is Dr. Sedhupathy, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today we are going to discuss about inter-process communication in operating system. So agenda for the today's discussion will be what is inter-process communication and what are the models of inter-process communication and inter-process communication in shared memory and in message passing systems. So basically inter-process communication within an operating system may be independent or cooperating. Cooperating systems or cooperating process can affect or be affected by other processes including shared data. Sometimes shared data may affect cooperating process. Reason for implementing cooperating process. You may be think like cooperating system can automatically affect or it can be affected by some other shared data. Then why should we go for cooperating process? The main thing is information sharing, computation speed up. When comparatively processes with independent, the cooperating process are so quick. So also the another reason behind is modularity and the convenience. So the cooperating process need inter-process communication. Basically there are two models of IPC. IPC is short form of inter-process communication. The number one is shared memory, another one is message passing. You know, the diagrammatic representation, how memory and process are handled in the shared memory scenario and in message passing scenario. While in the shared memory, there are common memory space for process A and process B. Both the processes are used in the common space. And there is a common kernel. While coming to message processing, there is no common shared memory space. Instead of that, there is a message queue in the kernel. And process A and B simultaneously accessing message queues. From the diagram itself, basically you can understand. And the producer-consumer problem is a basic example of shared memory concept or cooperating process. Producer produces a information that is consumed by consumer process. There are basically two types of producer-consumer problem for the shared memory scenario. Unbounded buffer and bounded buffer. Whereas in unbounded buffer, which places no practical limit on the size of the buffer, the producer never waits, it continuously produces information which is for consumption of consumer process. Consumer waits if there is no buffer to consume. If there is no buffer, consumer automatically waits because producer never waits whether consumer is consuming the information or not. While coming to bounded buffer, which assumes that there is a fixed size of buffer, producer must wait if all buffers are full. So basically the logic behind is mutual communication occurs, whereas in bounded buffer, in the unbounded buffer there is no mutual communication between producer and consumer. Consumer waits if there is no buffer to consume, like unbounded buffer in bounded buffer. Coming to IPC, inter-process communication, shared memory. There is an area of memory shared among the processes that wish to communicate. The communication is under control of user processes, not the operating system. So major drawback for the shared memory is to provide a mechanism that will allow the user processes to synchronize their actions when the access shared memory. Users unable to access but that particular shared memory. While coming to inter-process communication, message passing scenario. Here the processes communicate with each other using a message which is actually used shared common variable. The IPC facility provides two operations here for the message passing is like send message and receive message. If a process wants to share or communicate a thing to another process, it initiates a send message. And from the other side, the receiving process always have to wait for the receiving message from the sender message. The message size may be either fixed or variable, depends on the process scenario. Here the message passing is happens like if a process P and Q is to communicate, they need to create or establish a communication link between process P and Q, which is then further used to exchange messages via send and receive components. And basically, while implementing a communication link, we need to consider two basic things. One is physical and logical. Physical contains shared memory, hardware, bus and network, whereas in logical, direct communication or indirect communication, and synchronous or asynchronous type of communication, and automatic or explicit memory buffer. And here is the direct communication components. A process must name each other explicitly for direct communication, like send and receive, where send process names itself as P and the receive process have Q, and within the argumented parameter there is a message which sender needs to send to the Q, and from the receiver side the message it actually want to receive from P. And whereas in indirect communication, the mailboxes are used, directed and received from mailboxes. Each mailbox has its unique ID. Process can communicate only if they share a mailbox. And there is another concept, synchronization, which comes under message sharing or message passing. Message passing may be either blocking or non-blocking, which are all subtypes of synchronization. Blocking is considered as synchronous, non-blocking is considered as asynchronous. Whereas in synchronous or blocking sends blocked until message is received. The same way, the receiver is blocked until message is available. Whereas in non-blocking, the send always sends the message and continues, and non-blocking receives the messages or null message always. The different combination also possible in this synchronization. And coming to buffering, the buffering is nothing but a small size of memory or queue of messages attached to the link. The message is continuously attached to the link from one side from the sender, and the receiver always receives from the another side of the queue. The implementation in one of three ways, like zero capacity, which means there is no messages are queued on the link, sender must wait for the receiver, and bounded capacity, which is like fixed size of queue length, finite length of n messages sender must send, wait if the link is full. But coming to unbounded capacity, the infinite length of message queue can be available. Sender never waits for the messages to load it into the queue, and the receiver always waits from the queue. If it is null in the queue, receiver will wait. And thank you for dear learners for your patience listening. We look forward to meet you in the upcoming videos.